Now that we are done with Module 6, we will be moving on to our next unit and our next module. So for Unit 3, our third unit, we will be learning to solve equations and systems of equations. Module 7 is going to be focusing on solving linear equations. In our first lesson in Module 7 for 7.1, we're going to be learning to solve equations with variables on both sides, and the goal to go with that is to learn to represent and solve equations with variables on both sides. Now, in previous grades, last year and probably down into 6th grade as well, you guys learned how to solve some basic equations. So I want to start off this lesson in this module, and even this unit, by taking a quick look back at some previous equations that we might have solved, and talk about some of the terminology that we should have been using for solving those equations. So let's take a look at a couple of examples of lessons that or problems that we learned how to do back in previous grades. So for our first example, we have 3x equals negative 18. Now I know many of you are able to just look at this equation and identify very quickly what the answer is, and that's great, and that will be a skill that will be helpful in this module, in this lesson. It is important, however, for every single problem where we're solving an equation that we actually show our work, okay? We need to make sure that we're explaining our answers through showing work. I'm not okay with answers or with answers that you have where there's no work to support the answer, because I need to see the work that you do in order to get the correct answer. Now, I'm going to do two things here. I'm going to go ahead and we're going to actually solve this equation, but then we're also going to point out the key terminology that we need to use in talking about all the different parts and pieces of this equation. So let's start with that first. Let's talk about all the different parts and pieces of this equation. So the equation is read 3x equals negative 18. Now what that actually means is that we're taking 3 multiplied by some unknown number. X represents that unknown number, so we're taking 3 times x equals negative 18. This number that's in front of the x, this 3 right here, that's going to be what is called the coefficient. Alright, so that number that we multiply by is called the coefficient, and the number that we multiply that by, the letter that we have, that's called the variable. So the number is our coefficient, the letter is our variable, and then finally, our number that's all by itself, that's called the constant. So in every single equation, we're going to have these 3 important pieces of information: coefficient, variable, and constant term. And in order to be able to solve this, we need to make sure that our coefficient and our variable are on one side of the equal sign, and our constant term is on the other side of the equal sign. In this problem, that's the way it's set up, so we can go ahead and solve. So let's take a look at actually solving this then. So again, 3x equals negative 18. 3 times x equals negative 18. In order to get x by itself, and that is our ultimate goal. We want to have x all by itself, or whatever our variable is, we want to have x all by itself on one side of the equal sign. When we've got that done, then we are done with our problem. We're trying to get x by itself. We're trying to isolate the variable. Now, in order to do that, we want to use what is called an inverse operation. So, inverse, essentially that means opposite. So we're starting off on the left side of the equal sign. We are taking 3 times x, 3 multiplied by x. In order to take the inverse of 3 times x, we want to take and divide by 3. We know that multiplication and division are opposites. So, to do the inverse of multiplying by 3, we need to divide by 3. And so the way that we show that is by just putting a fraction bar with a 3 beneath it. Now here's why we do that. Initially, in the purple, we have 3 times x. Well, in red, we divide by 3. So what happens is that will cancel out, and we're going to be left with x. We have isolated the variable. We have that all by itself. Now, we want to make sure always keep our equal signs in a straight line going up and down. Our equal sign should always make a horizontal line going straight up and down. So I have my equal signs aligned just like this. And now I also need to remember that if I perform an operation on one side of the equal sign, I have to perform that same operation on the other side of the equal sign as well. So I already divided the left side by 3, and if I divided the left side by 3, I am required to divide the right side by 3 as well. So now, on the right side, I have negative 18 divided by 3. Well, one negative sign, I'll bring that down. 18 divided by 3 is going to give me 6. So my answer for this problem, which I'm sure many of you were able to see right away, is x equals negative 6. So all that we have to do to show our work for this problem is show that we're dividing both sides by 3. Other problems will have a little bit more complexity to them, but in this case all of our work was simply dividing both sides by 3. Now, it's my hope and expectation that you guys already know how to do that type of problem. It was just my intention with this example to go over some terminology, including coefficient, variable, constant term, and also just kind of get those memories of solving equations, solving one-step equations, kind of back to the forefront of our mind. So that first example, just a simple one-step equation. Our only step was to divide by 3. It's called a one-step equation. Let's continue our look back at equations that we've learned in previous grades with our second example, which will be a two-step equation. Second equation reads 1/2 x plus 8 is equal to 5. Now, with this type of equation, we've got 1/2. 1/2 is our coefficient, x is our variable, and now we actually have two constant terms. We have 8 plus 8, and we have 5. Our first step here needs to be to combine the constant terms together. So in order to do that, what I'm going to do is I'm going to do the opposite of adding 8. I want my constant terms together. I've got my variable now on the left side, one constant term on the right, so I want both my constant terms to go together over to the right side. So currently, I'm adding 8. In order to move that plus 8, I have to do the inverse operation. So the opposite of adding 8 would be subtracting 8. And that again will cause that to cancel on the left side. I'm going to bring down my equal sign. I always keep my equal signs aligned. I know that previous teachers maybe put a line going down where the equal sign is. If you want to do that, that's fine. I don't like that personally. But if you want to put that line down the middle of the equal signs to show that the equal signs need to stay on that line, if that works for you, then please feel free. I don't like it, but if you want to, that's fine. Since I subtracted 8 from the left side, I have to do the same thing on the right side. So now I'm subtracting 8 from both sides. Write down my big equal sign. I'm going to bring down my 1/2 x. My plus 8 and my negative 8 canceled right here. Bring down my equal sign, and now on the right side of the equal sign I have 5 minus 8 gives me negative 3. Now if you don't like this big gap right here, then don't write it that way. So 1/2 x is equal to negative 3. Now, to isolate our variable, we need to get rid of that 1/2. We're taking half of x. Half of x. In order to get rid of half of something, we need to double it. So we're going to end up multiplying both sides by the inverse, or the reciprocal of a fraction, which is going to be 2 over 1. That will make this fraction cancel. And if I multiply the left side by 2, or by 2 over 1, I have to multiply the right side by 2. We don't need the over 1, but I put it there just so that it makes sense. The half and the 2 over 1 cancel on the left side. So now I bring down my x. I've successfully isolated my variable. Bring down my equal sign. Now on the right, I have negative 3 times 2, which equals negative 6. Now to be honest with you guys, I just made up example 1 and 2 off the top of my head. I did not intend for both those answers to equal -6. It just worked out that way. So the answer for example 2 is also going to be -6. So this is another example of a problem that you guys should already know how to do these from what you learned in previous years. But if there was any part of example 1 and example 2 that was tricky or confusing to you, talk to me and let me know, or you can just go to Google and say one-step equation practice, two-step equation practice, things like that, and that will get you more practice on how to solve these with hopefully some examples. Go to YouTube, type in solving one-step equations or solving two-step equations, and that will walk you through the process a little bit more in detail on how you can go about solving these one and two-step equations. These are 6th and 7th grade skills, so if you need help with them or if you need more of a refresher, please let me know. But I do expect that you guys know how to do these types of problems at the start of this lesson. So going forward from here are the next examples that we're going to look at. We're going to look at probably just a couple more examples. We're going to be looking at examples where we have variables now on both sides of the equal sign. With example 2, we see that we only have a variable on the left-hand side. There is no variable term over here on the right-hand side as well. Okay? So with example 1 and example 2, the variables both happen to be on the left-hand side. It'd be okay if they were on the right. We would do the same process. But with the next few examples, we're going to have variables on both sides. Now there's some process to this, and I want to go ahead and write out the steps in which you can take to make sure that you're solving these problems correctly. Alright, so our steps for solving equations with variables on both sides of the equal sign. First thing that we want to do is we want to use inverse operations. So again, that means the opposite of the operation to get the variable terms on one side of the equal sign. Second thing we need to do is, again, we use inverse operations on any constant terms on the same side as the variable to move it to the other side of the equal sign. So what that means is if you have the variable term combined on one side of the equal sign, either the left or the right, it doesn't matter. If there is still a constant term on that same side, you need to move it to the other side of the equal sign before you can do anything else. Then finally, you divide both sides by the coefficient of the variable term. Let's take a look at some examples of what this is going to look like. For example 3, we have 7x plus 8 equals 3x. Now in this example, important to notice, we have two variable terms here, and we have one constant term. So, because we already have the variable isolated on the right-hand side, I would encourage you to move all your variable terms over to the right side. You don't have to. If you want, you can take this 3x and move it over here, but then you have to take this plus 8 and move it over here as well. If we simply move this 7x over to this side, then we're done moving things around. So in order to do that, right now we need to keep in mind that this 7x is positive. There's an invisible plus sign in front of there. So to get rid of that positive 7x, we need to subtract both sides by 7x. That causes these to cancel over here. I'm going to bring down my 8. I can drop the plus sign because it's assumed that it's going to be positive. I'm going to bring my equal sign straight down. And now on the right side, I have 3x minus 7x. 3 minus 7 is going to give me -4. And the x comes along. So now we're left with 8 equals -4x. And now it's just a simple one-step equation at this point. The opposite of -4, or I'm dividing by -4 on both sides. That's going to cause that to cancel, dividing by the coefficient. 8 divided by -4, bring down the negative. 8 divided by 4 is 2. So we have -2 is equal to x. So it's a variation on this two-step equation in that we had to first subtract 7x from both sides, then we had to divide both sides by -4, and then we got our answer of x equals -2. For a fourth example, we have x plus 5 equals 3x minus 1. First thing we need to do is identify our variable terms and our constant terms. So we have x and 3x. Those are both our variable terms. And then plus 5 and minus 1, those are our constant terms. Now, one thing that you may want to do, and this helps some students, but it is not required at all, you may want to put a coefficient of 1 in front of our x that doesn't have the coefficient written there. Anytime that you have a variable by itself without a coefficient, it's assumed and implied that the coefficient is 1. Now, we have a variable term and a constant term on both sides of the equal sign. So we could just start moving things around without any concern about what might make this problem easier for us further down the road. But what I like to do, I like to look at the coefficients. Here we have a coefficient of 1. Here we have a coefficient of 3. I like to move whichever coefficient is smaller. Doing so will ensure that we have a positive coefficient when we're getting ready to divide at the end. If I were to move this 3x over here, I would have to subtract 3x from both sides. 1x minus 3x is going to give me negative 2x. And it's okay to divide by negative 2, but I want to deal with positive numbers if I can. So instead, what I'm going to do here is I'm going to subtract 1x from both sides. And when I do that, these will cancel over here. I bring down my 5. I keep my equal sign directly below my equal sign above. 3x minus 1x I know gives me 2x. And then I bring down the minus 1. Now what I need to do is I need to move my constant terms all to the left side. I have my constant term over here. My variable term is on the right side. So I need to get rid of this minus 1. Well, the opposite of subtracting 1 would be to add 1. So I'm going to add 1 to both sides. That's going to cause these to cancel. 5 plus 1 is equal to 6, equals 2x. And our final step then is to divide by the coefficient of the variable. So we're going to divide by 2. 2's cancel. And x is going to be equal to 3. So with variables and constant terms on both sides of the equal sign, it's probably going to take us 3 steps. In this problem, it did take us 3 steps. Started off by subtracting 1x from both sides. Then we added 1 to both sides. And finally, we divided both sides by 2 to get our final answer of 3 is equal to x. Now, when you're going through and working on the Your Turn or on the homework, it might mention that you might want to use algebra tiles or something like that. If you have algebra tiles and that's something that you want to do, that's fine. I personally don't like algebra tiles. To me, they just don't make sense. So if you want to use them, feel free. If you want to look up how to use them, just Google using algebra tiles to solve equations, and you'll find some videos that will help you out with using algebra tiles. Alright, now I know we're getting a little long in the video, but there's still one more example that I want to go through. It's a word problem where we'll have to actually write our own equation from the word problem that we're given. Finally, for example 5, we have Andy's Rent-A-Car. It's just a name of a car rental company. Andy's Rent-A-Car charges an initial fee of $20 plus an additional $30 per day to rent a car. Buddy's Car Rentals, which is just a different car rental company, has a one-time fee of $36 plus an additional $28 per day. For what number of days is the total cost charged by the two companies the same? What we're expected to do for this problem is we're expected to set up an equation, and what's going to happen is we're going to have the information for Andy's on one side of the equal sign and Buddy's on the other side of the equal sign. Now, when we see things like initial fee or one-time fee, things like that, that is going to be our constant term. So if you go to Andy's Rent-A-Car and say, you know what, I want to rent a car, They say, all right, that'll be $20 plus $30 per day. You say, all right, good, let me get this car. They'll say, all right, here's your fee. And then you say, you know what, I changed my mind. They'll say, okay, you still owe us $20. Okay, at Buddy's, same thing. You go there, you walk in, say, I want to rent a car. You sign the contract and then say, you know what, never mind, I don't want to rent it. They'll say, okay, you still owe us $36. Okay, by signing the contract, you are responsible for that one-time fee or that initial fee. So, the initial fee, the one-time fee, those are not going to be multiplied by our variable. Those are going to be our constant terms. So for Andy's, we're going to start off with 20. And then we see that it's $30 per day. When you see that per day or per anything, that's usually a good sign that the number associated with that is going to be our coefficient and the days is going to be our variable. Now since it says plus, we're going to add and then 30 per day. So every single day we're charged an additional $30. Now that's the information that we need for Andy's. For Buddy's, we see that there's a one-time fee of $36. So that's going to be our initial value or our constant term. And then plus $28 per day. So that's going to be plus 28x. So now we have constant terms on both sides. We have variable terms on both sides. And we need to isolate our variable. So we need to move all of our variable terms to one side of the equal sign and our constant signs or our constant terms to the other side of the equal sign. So for solving this problem, I would encourage you, and this is just my opinion, I would start off by subtracting 28x from both sides. The reason that I choose to start off there is because 28 is less than 30. I would encourage you to always start off by moving the coefficient of the smaller coefficient to the other side. So to do that, we subtract 28x. Subtract it from both sides. And when we do that, that causes the 20x's to cancel on the right. On the left side, bring down the 20. And then 30x minus 28x is going to give us plus 2x. Make sure our equal signs are aligned. And then on the right side, the only thing that remains is 36 because the 28x canceled. So now our variable term is on the left side. So we want to go ahead and continue moving things until our variable term is by itself. That means that we subtract 20 because we remember there's an invisible plus sign in front of that 20. So to do the opposite, we subtract 20. And if we subtract 20 from the left, we must subtract 20 from the right as well. These cancel. Bring down the 2x. Make sure my equal sign is continually in a straight line. Equal sign in a straight line. 36 minus 20 is going to give us 16. Our final step then is going to be to divide by the coefficient. Our coefficient is 2, so we divide both sides by 2. 2's cancel, and x is equal to 8. So what that means is in 8 days' time, if you're going to rent a car for 8 days, it doesn't matter which company you go with because you will get the exact same amount. Now, if you rent a car for 7 days, one company would be the better value. If you rent a car for 9 days, the other company is going to be the better value. But if you rent it for 8 days, both car companies will charge you the exact same amount. We don't know what that amount is. We could figure it out by substituting 8 back into either side of the equation, but that's not part of the question. The question simply wants us to find out how many days it will take in order for the two companies to charge the same amount, and we found that to be 8 days. I know that this video has gone by, or has taken quite a bit of time, but I still feel like I've gone through it pretty quickly. If you have any questions or comments, please write those down and we will go through those in class tomorrow. After going through that lesson, I hope that we have a better understanding of equations with variables on both sides, and that we have learned to represent and solve equations with variables on both sides. Tomorrow we'll get to the more represent part. Today, I'm hoping that we just have a better understanding on how to solve equations with the variables on both sides.